Yo guys, this is the first video for exponents and sets, and the first section that we are doing is laws of exponents. I thought maybe just to do a refresher, I'm not going to go through the laws, but just a refresher. We have the first definition saying that a to the power of n is equals to a times a times a. Basically, you are multiplying a by itself n times. That's what the first definition is saying. And if we go to the second one is basically saying any base to the power of 0 is equals to 1. But it's not just any base. This excludes 0 because 0 to the power of 0 is undefined, right? So it's not part of real numbers. Exactly. And the third definition says that if you have a negative exponent, it becomes what? It becomes a fraction. So basically, I think I can write it nicely here and say, let me just say to the power of n, right? Which makes it 1 all over a to the power of n. That's much better. So if you have a negative exponent, you're going to have 1 over a to the power of that, let me just say n. You have a to the power of negative n. That negative, gets into 1 over. Then you have your a to the power of n. Then you're done. But you have to know that we cannot at any point have 0 as our denominator. So in this case, again, a cannot be 0, right? That's sweet and nice. Make sure you understand all of this. Just make sure you understand everything here. Now, before we start solving some nice problems, let's get into something which is more interesting as well, laws of exponents, right? So the first one, you are seeing here we have a to the power of m multiplied by a to the power of n. And the answer is a to the power of m plus n. What that says is that if you multiply numbers that has the same basis, you're gonna add the exponents. You see here our basis is the same. It's what? It's a. So we just add the exponents. Just to make an example, I can have 2 to the power of 3, multiply that by, say, 2 to the power of, let me just say 1. So I know the answer to that is gonna be 2 to the power of 3 plus 1, which is 2 to the power of 4. And you can either press the calculator, but it will be nice if you know this by heart. All right. So that's basically what the first laws of exponents saying. The second one is quite the opposite of the first one. Here we have the same basis, but we are dividing instead of multiplying. And you see that the answer is subtraction. A to the power of m over a to the power of n. That answer is a to the power of m minus n, right? Making an example again, say we have 2 to the power of 3 divided by 2. We know this 2 is to the power of 1, of course. So the answer to that is going to be 2 to the power of 3 minus 1, which of course is 2 to the power of 2. And you have your answer, right? Cool. The third one is quite simple as well. Basically here we have a product of AB, right? And let me also write that A is to the power of 1 and B is to the power of 1. So basically here you can say, what do you have? You have A to the power of 1 multiplied by what? By n, right? Multiplied by B1 times n, which makes it a n b to the power of n, right? So in simple terms, law number 3 says that when you are raising power to power, you're just multiplying the exponents, right? And that's just what law number 3 says. Let's go to number 4. Number 4 is also saying the same thing as number 3. It's just that here, instead of a product, we are dividing a divided by b to the power of n. It's the same thing. You know, you have your 1, your a to the power of 1, your b to the power of 1. So we're just going to multiply these exponents, right? That's just it. Law number 5, and I believe this is the last one. Then after that, we're just going to do some fun problems. Yeah, basically the same thing that law number 3, law number 4 was saying, that if you raise power to power, you multiply the exponents, right? Here, number 5, you have a to the power of m all to the power of n, right? So we have an exponent of m, we have another exponent of n. And when we are doing that, raising power to power, we just multiply the exponent. The answer is a m n. Let me make an example. You have 2 to the power of 3 to the power of 2. The answer is 2 to the power of 3 times 2, which is 2 to the power of 6. Then you're done. But of course, you'll have to write this answer in its simplest form, right? So, guys, that's basically the laws of exponents. These are the definitions. And yeah. Yeah, I believe now we're done with the definitions. We are just ready to do some more fun. Oh, by the way, the last thing is that in law number 1 up to number 5, know that a and b, which is our basis, they have to be positive, right? Yeah, so basically they will be integers, both of them, and they have to be positive. So they are positive integers, right? And I believe that's just about it with the laws of exponents. In the next video, we will just be solving problems, a few problems, just to test our knowledge on this. Make sure to repeat the video before watching the next one, because you don't want to be confused, right? Yeah,